So this video is to continue the derivation of the cosine of the difference of two angles. So we're trying to figure out what is the cosine of alpha minus beta. And you'll notice that it's part of this stuff up here. So what I've done is I've taken the picture from the first video where I had that angle alpha and the angle beta. And so this guy here is alpha minus beta. And it creates this angle up here with a couple of points in the unit circle. So x2, y2, because that angle is alpha, has coordinates cosine alpha, sine alpha. And in that same black little angle up there, x1, y1, because this angle was beta, x1, y1 was cosine beta of sine, sine beta. Then what we did was we rotated that angle so that it was in standard position, but it's still the same size, alpha minus beta, whatever that number is, it's still the size of that angle. It's just now written in standard position. But now the coordinates for this second triangle, x2, y2, is the point on the unit circle where in standard position alpha minus beta's terminal side goes through the unit circle, and so its coordinates are cosine alpha minus beta comma sine alpha minus beta. And because it's in standard position, this first dot over here have coordinates 1 comma 0. And so what we're doing is we're going to do a bunch of algebra with the expressions for the square of the distances between these 2 points. If these angles are the same, those triangles are the same, and so the black D up here in the black triangle is the same as the orange D down here in the orange triangle. And since the D's are the same, the D squares are the same. So I've got a black D squared that I'm going to work on for a while, and then I've got an orange D squared that I'm going to work on for a while, and they are equal. So at the very end we'll set them equal and we'll see what we get. So let's start with the black triangle first. And so what we said was that that's the black triangle, so sorry about that. What we said was that D squared is the quantity cosine alpha minus cosine beta quantity squared plus sine alpha minus sine beta squared. Now these are just squares of binomials. It's just cosine alpha minus cosine beta times cosine alpha minus cosine beta, and then plus this other guy. So I'm going to work on this first one because the other one comes out the same and I'm out of space there. So with FOIL, I've got cosine alpha times cosine alpha. That's cosine squared alpha. And then I've got cosine alpha times cosine beta, but it's negative. So I've got negative cosine alpha cosine beta. Then I've got that again. That was my outside terms. My inside terms are again cosine alpha times cosine beta, but negative. So I've got another one of these cosine alpha cosine betas. And then finally minus cosine beta times minus cosine beta. Minus is plus cosine squared beta. Identical thing going on with this other piece. So that one, when I square it, is going to be sine squared alpha minus sine alpha sine beta minus sine alpha sine beta again, and then plus sine squared beta. What's great about these expressions is a lot is going to simplify. I know it's a lot of terms. It's what, 1, 2, 3, 4, 8 terms altogether. But the cosine squared alpha plus sine squared alpha, that's Pythagorean theorem. Sine squared alpha plus cosine squared alpha, that's just 1. Similarly over here, cosine squared beta plus sine squared beta, that's also 1. So put those 1 plus 1 together, and that's just 2. Then what do we have? We have 2 of these minus cosine alpha cosine beta. So that's going to be minus 2 cosine alpha cosine beta. And then same with the sines. Minus 2 of these sine alpha sine betas. So this looks good. This is what I've got when I simplify that left-hand side. Let's kind of keep that. I mean, I can always come back to this page, but I'm going to write that down on my notes before continuing on, and you probably should. Watching this video, you should go, okay, so the black triangle, square of its distance, we've simplified that to 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. So let's look with the other triangle. So the orange one here, and I'm going to do the work in black, but the orange one over here, the d squared, is quantity cosine alpha minus beta minus 1 squared plus sine alpha minus beta minus 0. So who needs that? So I'll just call that sine squared alpha minus beta. So let's look at how that simplifies. Hopefully it simplifies as well. So we're now looking at the second triangle. So for that second triangle, the square of the distance is going to be cosine of alpha minus beta minus 1, quantity squared, and then just plus sine squared alpha minus beta. So let's simplify that guy. So once again, I've got a binomial squared. So this first one, I've got cosine alpha minus beta times cosine alpha minus beta. It's cosine squared alpha minus beta. And then my outer term is going to be negative 1 times cosine alpha minus beta. But my inner term is exactly the same thing. It's going to be negative 1 cosine alpha minus beta. And then my last is negative 1 times negative 1. So that's that entire thing that I have underlined in orange. And the other piece is just sine squared alpha minus beta. Okay, cool. Once again, we've got sine squared of something, sine squared of alpha minus beta, plus cosine squared of alpha minus beta. That's just 1 again. And so that one goes with this one. There's a 2. So this comes out to 2 again. And then minus one of these and minus another one of these is minus 2 of these cosine alpha minus betas. And so that expression is what the square of the distance for the second triangle comes out to. And I'm going to write that down. So the first triangle we have already written down. Now here's the square of the distance of the second triangle. I know that those are equal. The distances are equal. The d's are equal. And so the square of the d's are equal. So I'm going to set our two expressions equal to each other. I'm going to say, all right, so 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. That's the same as 2 minus 2 cosine alpha minus beta. I'm going to subtract 2 from both sides. Subtract 2 from this side, subtract 2 from that side. And then I'm going to multiply both sides. Well, you know what? There's a lot of ways to do it. Yeah, I'm going to go ahead and do it. I'm going to multiply both sides by negative 1/2. So the 2's are gone. Why don't I even... Yeah. So the 2's are gone. I'm now going to multiply both sides by negative 1/2. Reason being, there's a negative 2 everywhere. Oops. I said negative 2, so I wrote negative 2. What I'm doing is I'm multiplying by negative 1/2. And when that negative 1/2 sees that first term, negative 1/2 times negative 2, that's just positive 1. So the left-hand side is now going to be positive cosine alpha cosine beta. Then when that negative 1/2 by distributive property hits this term, same thing happens. Negative 1/2 times negative 2, that's positive 1 times sine alpha sine beta. And then here on the right-hand side, same deal. When that negative 1/2 hits that one term over there, negative 1/2 times negative 2, that's positive 1. Pardon me. Go Giants. Is cosine alpha minus beta. So typically, the way you see this is that cosine of the difference of two angles is equal to cosine of the first times cosine of the second plus sine of the first times sine of the second. And sorry that took so long, but there is the cosine of a difference identity.